The first problem, it gives us a joint density function of x and y, and unknown variable a. And question number 1 asked us to find a valid find a so that fxy is a valid joint density function. So if it is a valid joint density function, the integration of this function should be 1. So we do the integral of this function, and we will get the result is 4 over a, and it should be equals to 1. Therefore a is equals to 4. And question 2 and 3 asked us that whether x and y are correlated or independent. And so in order to check whether it's correlated or independent, we need to calculate the expectation of x and xy. So for the expectation of x, we can calculate that the result is 0, and for the expectation of x times y, the result is 1/9. So the expectation of x and y is not equals to the expectation of x times the expectation of y. Therefore xy are not correlated and they are not independent. And for question for the fourth problem, it asks us to find the joint density function of x squared and y squared. So first, we need to calculate the Jacobian matrix using the derivative of several parameters, and we will get the Jacobian matrix, which the Jacobian result is 4 times x times y, and we can let z equals to x squared and w equals to y squared. So when z is from 0 to 1 and the w is also from 0 to 1, the Jacobian value should be 4 times square root of z and times square root of w. So the density function of zw, the Jacobian will have 4 roots, which is negative and positive square root z and negative and positive square root of w. So total there are 4 roots. So we can write in this form. We have 4 terms, and we can plug in these values, and we will get the result that the joint density function of zw is 1 over 2 times square root of b times 1 over 2 of 2 times square root w. And for other z and w values, the density function should be 0. So to sum up, the density function of x squared and y squared is 1 over 2 times square root of z times 1 over 2 times square root of w. And the fifth question want to know whether x squared and y squared are independent. So if they are independent, the marginal density function they times together should be equals to the joint density function of z and w. So we can calculate the fz, density function of z. We do the integration and we'll get the result, which is 1 over 2 times square root of z. And similarly, we can get the density function of fw, which is 1 over 2 times square root of w. And we can see that the density function times together is equals to the joint density function. So x squared and y squared are independent